afternoon, Year 7s and 8s. I hope you are all well and keeping safe. So, Friday's lesson is going to be a culmination of the renewable and non-renewable resources that we looked at in the previous week. Remember to watch the video all the way through. Don't just skip to the end. Make sure that you write the answers down for the remember questions coming up. If you can't write them down somewhere, try to ask somebody to ask you the questions. Okay, so let's get going. So I hope you are happy that this is the periodic table. I'd like you to look at this part here and then look at any of the elements that you find in your periodic table. Can you tell me the atomic number? Can you tell me the atomic mass? Can you tell me the short symbol and the element's name? For example, if I looked at this one here, could you give me all of those details? So pause the video now and have a look at that for me, please. Okay, so I hope you pause the video. So this one will be Li with the symbol short version, and that stands for lithium. The atomic number will be 3. Tells me it has 3 protons in its nucleus. And here the atomic mass will be 7, telling me that it has 4 neutrons. So 3 and 4, as we know, make 7. So the basis of our periodic table. So what are the columns of the elements called? I hope you remember this from Mr. Samuel's video. So pause the video now and try to remember what I would call the columns of the element. Okay, so as we should know that these are called groups. I have group 1, group 2, group 3, group 4, group 5, group 6, group 7 and group 0. Not group 8. The reason why they are is because group 1 has 1 electron in its outer shell, group 2 has 2, group 3 has 3, etc. until I get to this one. It means it has a full outer shell, not always 8. For example, helium only has 2 electrons in its outer shell, it doesn't have 8, so it's called group 0. So my groups go down. Now, what are my rows called that go across? My horizontal rows. Okay, they're called periods. So period 1, period 2, period 3, all the way down to period 7. Okay, so our groups and our periods, we can use those to identify elements. So I would like you to answer the following. Group 1, period 5, group 2, period 2, group 8, period 4, group 17, period 3, group 5, period 2. I would like you to write down which symbol they are. I would also like you to tell me what their atomic number is. So pause the video now and answer those questions, please. Okay, so hopefully you pause the video. So the answers are, that is for answer 1, group 1, period 5, group 2, period 2, group 8, period 4, group 17, period 3, and group 15, period 2. I'm not going to tell you the names because you should know them. If you are struggling with this, guys, please go back and look at Mr. Samuel's video. So, moving on, matching these key words to their definitions. You should be 100% sure with these now. Again, if you are not, please go back to the previous lesson. So I'd like you to write out these key words and then match them to their key definitions. So pause the video and do that now, please. Okay, so my atom is the smallest part of an element that can exist. My element, substances only made up of that one type of atom. So for example, gold is only made up of gold atoms. My compound, 2 or more elements chemically bonded together. They are only a compound if they are chemically bonded together. So finally, my mixture is 2 or more elements or compounds not chemically bonded. So make sure you've got this correct. Make sure you've written those keywords and then their key definitions. Okay, moving on. So, states of matter. I would like you, especially if you're in school, to draw the solid, the liquid and the gas states of matter by using a box or a circle and denote what the atoms would be doing. I would like you to look at this graph and can you tell me what happens between the different states of phase in my solid, my liquid, my gas. Ideally, if you could even draw the graph if you're in school, you can do it at home and tell me what would my particle arrangement be for a solid, what would it be for liquid and what would it be for a gas. So pause the video now and have a go at that for me, please. Okay, so I'm going to play the animation and it will explain and demonstrate again the difference between a solid, a liquid and a gas. So, a solid, the particles are touching, they vibrate very, very slowly, okay? So they're going just to that solid phase here. When they reach the melting point, okay, I'm going to rewind this a little bit. It's important when they reach that melting point, they don't all go literally from a solid to a liquid straight away. It takes some time. So as you can see there, some of those are still touching and some of those are not. So we're now going to fully move from a solid into a liquid. As you can see, they are gaining enough energy to start to move apart, my liquid phase. And now we get to our boiling point. Again, it's important to note they don't all go from a liquid to a gas straight away. There we go. And the boiling point now. And now they are a gas and they are bouncing around quite happily. Okay? So, states of matter, change of state. Again, if you're not happy with that, please go back and look at the video. So we're now going to we're going to watch two very, very short videos, about 2-minute sheets each. One is on renewable energy and one is on non-renewable. You should be very, very happy with these by now. Okay, so here are the two videos for you to watch.
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period, approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms, like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
Okay, so that was fossil fuels, okay? Non-renewable energy. So coal, gas, oil, made from remains of plants and for the Carboniferous period. So we're really happy with those. So we're now going to look at renewable energy.
Renewable energy. Renewable energy is a term used to describe a group of energy technologies derived from sources that do not deplete or that can be replenished within a human's lifetime. The most common renewable energy sources are solar, which harnesses the sun for energy; wind, which utilizes the motion of wind to create electricity; hydropower, which uses moving water to generate power; biomass, which refers to a large group of technologies that use living or recently living organisms and waste to create energy; tidal. Tidal uses the rise and fall of the tides to create electricity; geothermal, which uses the internal heat from the earth for energy. Nuclear energy is not considered a renewable energy source. It is considered an alternative energy source. While renewable energy accounts for a minority share of the world's energy supply, it is also the fastest growing energy supply on the planet. Renewable energy is sought after because it is a clean source of energy, meaning that it does not directly produce greenhouse gas emissions or air pollutants. While renewable energy sources are better for the environment, they also face several challenges, the main ones being low efficiencies, high capital costs, and intermittency. That's renewable energy.
Okay, so you've looked at renewable there, and you've also looked at non-renewable in the video beforehand. So you should be all caught up to where you are for this week. Now, this week's challenge takes a little bit of explaining, so you're going to have to be listening carefully. So, I would like you to imagine that you have won the national lottery. You have won as much money as you would possibly like. However, there are some rules to you winning the national lottery. And one of them is that with it comes an island. As you can see, it is a lovely island in a lovely blue turquoise sea. Now, you may think it's all very well having your own island with all the money, but it has no energy. It has nothing to make energy on it. So, you are the owner of a newly discovered island. You need to choose 2 energy resources to help you power your island. 1 renewable and 1 non-renewable. You must decide which 2 you're going to use, where they will be. Draw this on your map. Give key details of your chosen energy resources and justify them. List the advantages and disadvantages. So, I would like you to draw Google Doc, PowerPoint, anything you want to, photo, video, uplink, model, anything. A tropical island. You can have on it what you want. I've done this for my class in school today, and we've gone from a gaming island all the way through to a party island. So you can have on it what you want, guys. Your imagination is the limit. But you need to have energy. 1 needs to be renewable and 1 non-renewable. Tell me the benefits, tell me the disadvantages of both types, please. It has to be surrounded by the sea. It has a mountainous region in the middle. It has deposits of fossil fuel along the coast. It is windy in the winter. They are the only things that will limit you. So I would like Google Doc, PowerPoint, Word doc, poster, any way you can show me what you have learned by doing your extension task. Okay? You could do a model. I don't mind. Surprise me. We've had some really, really good work sent in this week. So please, please, please upload your work and show me. So I'm going to finish this week by just saying some shout outs to some students who've done some really good work. There are lots of you out there sent some work in. So I'd like to thank Benjamin Clark and Sahir Boisel. Sahir, if I pronounce that wrong, I hugely apologise, for some fantastic videos on exercise. Cleo Rains, Liliana Heslop, Susanna Limbu and Josh Stokes have constantly in the last 2 weeks submitted some brilliant work online. Guys, I'm getting lots of work uploaded or saying you've watched it, but some without any written work attached. I want to see your work, guys. I know you're out there working. Show me, all right? If you see me around school, if you need help, come say, hey, Mr. Burns, can I have some help? If you get stuck at home, my email is there. It sent a letter out to all the Year 8 parents, so you know my email. Right, let's see this work, Year 7s, Year 8s. I know you're doing it, so let me see it. Right. Until I'll speak to you next week, have a good weekend. Stay safe. It's going to be not bad weather this weekend, so enjoy the weekend. And if I see you around school, come say hi. If not, I'll speak to you next Friday. Take care, guys. Keep safe.